Good evening. Welcome to this evening's TI Technology webinar, hosted by Texas Instruments. Thank you for participating in this virtual conference, where we will take a look at exploring quadratics with TI-Nspire Technology. I see that many of you are joining for the first time, so we'd like to offer a special welcome if this is your first T³ professional development webinar. We'd also like to thank everyone for completing the survey. My name is Stacy Thibodeau. I am your moderator for tonight. I have taught science for over 20 years, including Biology 1, Chemistry 1, and AP Chemistry 2. I have also taught in the Biomedical Sciences courses and Project Lead the Way program. I love to use TI technology to assist teaching, data collection, modeling mathematics concepts, and linking them to science concepts. Tonight, we have our presenter, Ms. Kim Thomas. Kim is in her 25th year of teaching high school mathematics and is passionate about using technology as a tool to explore and understand mathematics. Kim has taught the spectrum from Algebra 1 through BC Calculus and is currently teaching geometry and BC Calculus. Kim is a National Board Certified Teacher who was named one of the 2019 Arizona State finalists for the Presidential Awards for Excellence in Math and Science Teaching. As a T3 national instructor, Kim enjoys working with teachers, helping them to incorporate effective strategies for teaching with graphing technology. Thanks for being with us, Kim.
Excited to be here this evening.
We're expecting a large crowd, so your audio is muted. Feel free to send questions to all panelists using the Q&A window on the right side of your screen. We also will send general messages in the chat window. This session is being recorded. As a reminder, we will provide a link to this event's certificate of attendance at the conclusion of the webinar. Once the recording is available, if you would like to follow along with your handheld or software, and we hope you will, we recommend doing this with the recording so you can download the activities and pause and rewind the recording as necessary. We don't expect you'll have any audio issues tonight, but in the event that you do, try selecting Communicate in the WebEx menu, Audio Broadcast, and then click Join. Kim, I'm going to go ahead and turn it over to you.
All right.
And you can share your screen.
Awesome. All right. So again, thank you for spending your late afternoon, early evening with us. This is such a wonderful opportunity to share and learn together. We're going to be exploring quadratics, and this is such a big, huge subject that there's no way that we can touch on everything. So I just picked a couple things to talk about, and I'm sure that I won't get through my entire list. The goals for this evening is that I want to go through a couple TI ready created resources for you, and how I would use those in my classroom and other ways that we could explore using them. And then we're also going to do some problems with quadratics using just the built-in features of the TI-Nspire CX technology. And so I'm focusing mainly on the software, but obviously this stuff can be done on the handhelds as well as the iPad as well. So it's kind of nice. And then of course, the major goal of the session is to have fun with quadratics. In the WebEx setting, there is a chat feature. And so when you're using the chat this evening, if you would send to all participants, that way we can see the answers. And I do have a question for you guys, and I'm going to do this throughout the session. So I want this to be interactive. I know we won't be discussing back and forth verbally, but we will be in writing. So what skills do we want students to have connected to the subject of quadratics? Go ahead and just chat, type your answers into the chat. So one suggestion is graphing. And I assume that that would be graphing by hand and graphing with technology. We want to find solutions. We want to identify features of the graphs like maxima, minima. We want to be able to find zeros and understand what they mean. Identify equations, understanding behavior and key features. I want them to recognize that this is actually a quadratic, like actually knowing what a quadratic is. Looking at pattern recognition from the function, modeling real world stuff, connecting equations to graphs, different applications like area, patterns, and finding solutions are some answers right there. And I would say that those are the things that I listed. When I did skills, the only thing that I was a little bit more specific and I said factoring. I did say solving. And I also put in transforming. So I want them to be able to transform functions. And function would be a quadratic. That's the skill question. And so I want you to think a little bit deeper. I know it's the end of the day, but what kind of relationships, and we kind of mentioned a couple of these with the skills, but what kind of relationships or ideas, characteristics, or facts do we want students to know about quadratics? And so one idea that's listed is the idea that the quadratic could have an interval where it's increasing. We can have an interval where it's decreasing. With that, we also have intervals where the function is positive and where the function is negative, and those are two completely different concepts. The rate of change idea, how they relate to the areas of things. Looking at the effects of A, B, and C upon a graph. The second difference constant. And some other things there. So there's lots of things to do with quadratics. It's a big, huge topic. And so I hope to touch on a couple of those things because I know that we definitely will not be able to do all of them. So the first activity I wanted to talk to you about is actually from the Math-Inspired site, and it's under Algebra 2 and Quadratics, and it's the completing the square activity. And this is something that completing the square, you know, when we look at our Common Core standards or our state assessment standards, completing the square is something that we expect students to have the skill to do at Algebra 1. When we're in Algebra 2, we revisit that skill, and we have different purposes for completing the square. As a calculus teacher, we use completing the square when we're integrating. So this concept of completing the square comes up at all of our levels throughout our curriculum. And so sometimes we need to teach it just from the beginning, and other times we need to review it. What I liked about this particular activity is that this is really working with manipulatives, but we're working with virtual manipulatives. So if students have access to computers, they can load the TI-Nspire software onto their computer and they can work with this. And so this is loaded just straight off the TI website. And it says we're going to use algebra tiles to build a perfect square. Note the equations of the perfect squares and just very simple directions. And we're just going to go to the next page here. And on this page, there's a little question mark here, and it will tell you more directions. And when I use these types of files in my classroom, I usually provide and model these directions instead of having students read them. But when students are exploring on their own, they need to press the buttons and see what's going on. So we're going to build algebraic expressions by dragging tiles onto the mat. We're going to drag the X tiles by grabbing the center. We can turn and click them by pressing either end or with a T. Escape will deselect, R will reset, and we can also set the X values. And so we can drop the tiles below to the right, place them, and press escape or click to continue. And then there's more directions here. So you also may press X to select an X tile. We may press S for X squared. The unit tile, press 1. For negatives, first press the negative. So there's different ways to do this. I'm going to exit out of this. And what I want to do first is I actually want to work with the square of x plus 1 quantity squared. And so this is reviewing the area model. So I wanted to work with x plus 1. And I want to take this expression and I want to square it. So I actually want to make this an expression squared because I think that's something that students have a hard time with. And so if I'm working with the area model, and these just move around wherever you'd like them to go, we can drag in the x squared and notice the things that are changing here. So I have this expression here. I have x squared plus an x plus a 1. And then it's evaluating this expression for me at 3. And so I have x squared plus x plus 1 with x equals 3, and that's 13. And if I'm trying to complete the square, that's not quite a perfect square yet. So that's something that we can explore here. Now, I also have this factors off. I'm going to turn on factors on, and nothing happened. Well, why did nothing happen? And nothing's happening because x squared plus x plus 1 is not factorable under the real number system. So I need to do some more things with this. So I'm thinking that if I wanted to make this into a square, I'm missing another x. So as soon as I drag it onto the mat, it's factoring for me this x squared plus 2x plus 1, this area model here, into x plus 1 times the quantity of x plus 1, which is my quantity of x plus 1 squared. And I can see that, and I can also turn it into a square if I want to. It's not mandatory that I need to put it into a square, but for me, that visual of this is what a square is, and the fact that the length and the width are equal values is very important. And then we also have this expression down here. And so this is a way for students to actually get some feedback, because sometimes when we work with manipulatives, we get the feedback that we have the square, but we don't necessarily get the feedback of the factoring with the expression up here. So this action and consequence here is really kind of important. Now, what's also kind of cool about this is if I increase the values for x, it will evaluate the expression with that value in here, and I can see that this is a perfect square value. That doesn't necessarily mean that this, as I'm doing this, this is scaling them and it's kind of making it hard to read, but I do have that ability to do that. I'm going to reset it. I'm going to do another one. And so what about x plus 2? So if I'm starting out with x plus 2, I'm just going to put x plus 2 here. And again, if I want to square this, there's many different ways that we can explore this. And we don't even really have to use this for completing the square. We can actually just use this with multiplication if we wanted to. Because if I wanted to square this, that means that I would have this x plus 1 here. I'm just going to move this down. But I know that I would have to have an x and another x here in order to get the square. So some things that we're kind of thinking about right here. So I know that I was working with x plus 2 quantity squared. And when I have this x plus 2 quantity squared, we can see that we definitely don't have a square yet. These are all kind of a little, they snap together, but then they don't snap together. So we're not quite there. And again, I don't have it factored. Now the factor's on, it's not factorable. So if I did x plus 2 quantity squared, if we think about it, we should have 2 times 2, which would be our 4. And so I would have to have 4, a constant of 4 out here. Again, that's not quite it. And remember that we'll have the numbers. We should really have the 4x to get that. So again, it's providing that problem solving piece. And I think sometimes these activities are overlooked on the TI website, or we don't know how to use them. And maybe we want to use them differently than intended. And I just want to kind of, offer up that exploration of where we can do that. And, it's not always important to turn it exactly into a square, but that would be something that would be good here. So I'm going to go ahead and put this one here. Kind of play with it. And this is where it's also very valuable when you're working on the software. This might be easier to do on the software than it is on the handheld. And I haven't recently put this on a handheld to know that, but there's other things that we can do as we're modeling that. So that activity is completing the square, and it did come from the TI website. And when you download that activity, you will get a teacher document that actually walks you through different questioning techniques. There's always a student handout so that the student can actually record their information. So this one really had a chart where you were supposed to put the sides of the squares on there, then actually write out the perfect square, look at the coefficient of the x terms and the constant terms, and look for patterns and other different things. So a very, very valuable activity that will work in the classroom or in your virtual world. So the other activity that I wanted to talk about is I wanted to talk about discriminant testing. So this is another activity. It also happened to be in the Algebra 2 world here. And it's another one that we can just download to our calculators. We could provide the link to our students and say, go here and download it to your computer and put it on your software. If they're working on an iPad, it works very much the same way. You can go to the link and then you can upload it in there. And for this one, we're looking at discriminants. Kind of do this right here. And so the file says we're going to use the following pages to determine the relationship between the value of the discriminant and the nature of the roots of the quadratic function. So we're going to have a quadratic function, and if we're using this in class, we would actually have to make sure that we have all the correct terminology and that we have the prerequisite skills in order to do this. So I'm going to go to this first page here. And on this first page, the one thing that's real important for students and for teachers is to actually just stop and pause. And what do you notice? What do you see? And so for this one, hopefully we're saying, well, we see a quadratic here, and we have an A, we have a B, we have a C. So those prerequisite skills is we have to know what those A's, B's, and C's represent. It makes sense that if we know that A is the coefficient of the quadratic term, the x squared term, that this is facing downward and it has a relative maximum. We have C is -5, and that would be the y-intercept over here if this was in standard form of ax squared plus bx plus c. And we have this D right here, which is that discriminant piece, and they've put that together. So we have to know that our discriminant right here is positive 16. What's cool about this one is that we can have a whole bunch of examples. So what I'm going to do is I'm going to ask you to think about this as I'm going to give you your examples. So I want you to notice something about the values of the discriminants, and then maybe think about the graphs of the quadratics as well. So I'm giving you two ideas to think about as I'm going to change these. So I have this file and I'm just going to press the slider, and what do you notice about the discriminant? So if I'm in my classroom, I would be making a chart and I would say I have an A is 1, a B is 10, a C is 20. The discriminant happens to be 20. And I have an A is 1, a B is 10, a C is 23. The discriminant is 8. I have an A of -1, a B of -4, a C of 1, and the discriminant is 20. And then now I have a discriminant of 8. So in the chat, what are you noticing about all of the discriminants? And we're saying that, okay, all the discriminants happen to be positive every single time. And as I flip through here, I've had some negative A's, I've had some positive A's, I've had some positive C's, I've had a C as a 0, I've had C as a negative. So I've been changing the values. My A's have been positives and negatives, my B's have been positive and negatives, my C's have been positive and negatives, but every single time the discriminant has been positive. So if I have a positive discriminant, what do we notice about the graph? So presumably for students who have not done this before, hopefully they can make the connection that if I have a positive discriminant, what is true about the graph here? And I see some people typing in the chat that that means that there are now I see 2 intercepts, and I also see 2 real zeros, and I see 2 x-intercepts. So that's actually a really good thing to talk about with students, because I'm just going to use one feature of the TI-Nspire. I'm going to press a P. And when I press P, it allows me to put a point on this curve. So right now, this is an x-intercept. We have a y-intercept, and we have an x-intercept here. So when I'm looking at this graph, I want to make sure that when I'm talking about the discriminant, I'm really looking for the fact that I do have 3 intercepts, but hopefully I want them to get to the idea that there happens to be 2 zeros. And I will tell you, in my classroom, I might just write down something and say, yep, you guys told me about intercepts. You also told me about zeros, but I might not give them the answer yet because there's another problem. So in the TI-Nspire, when you're in problem 2, it's not connected to problem 1. So we're going to start back over and we're going to go to problem 2. And we're going to follow the same routine. So this routine gets a lot faster as we're looking at it. So in this one here, we have A is 1, B is 0, C is 0, and we have a D, which is 0. And so I'm going to change this up, and I have another D that's 0, another D that's 0, another D that's 0. And so as I'm looking at these, it appears that the discriminants are all going to be 0 on this page. Now, as we're looking at it, what's different about the graphs here? This is one thing that I really like about my TI-Nspire software, is that if I just change my view right here, so I can have the calculator shown. And that's important when I have to teach students how to use the calculator where I'm working with people and we need to know the mechanics. But sometimes I want to see the slide and I want to compare the previous page to this one. So one strategy is to actually have my screen to where the previous window is here when we talked about these blue graphs and we said the discriminants were all positive. And then we have this screen right here that's active. This is the only one I can really act with. But I can see that the discriminants are all 0 and I can make the next prediction. And so I'm seeing people type in the chat that there's only one solution. I see 2 real duplicate X. It's another way to see it, because at this point in time, if we've done solutions before, we've told kids there's always 2 answers, but what kind of answers are there? So there's one repeated root is one way to do it. Sometimes I'll say there's one unique root, but there's still 2 answers, and it's this value right here. So that's one way to make that comparison. And then when I don't want to look at that, I just can go back to here. And then we're going to go ahead and do this one more time. And we're looking at 3. And we can see that these discriminants are all going to be negative. As math teachers, we kind of know the punchline, and we can see that these graphs are never doing what? They're never intercepting on the x-axis, and so this is where we would have 2 imaginary solutions. We don't have any real solutions. There's no x-intercepts, and that would be one thing that we can kind of work with. And again, I can compare it to the previous one and the one above it if I want to look at that and see what's going on. Now, one thing that I wanted to kind of bring to people's attention is this was a file that was made by someone else. I did not make this. I downloaded it from the TI site. And again, they had a beautiful chart that asked you to kind of look for patterns and things. But there's one thing I didn't exactly like about this one if I was teaching discriminants in my classroom, and that's the fact that I would want to see the equation of this particular parabola. And so I'm going to go back to problem 1 because I think that's where I would have brought this up in my classroom. I would have had my whiteboard on the side and I would have written out the equation of this parabola and I would make them do some calculations because it's not all just about seeing and watching. It's also about doing math. And so one thing that you can do when you're on the screen is you can go into the menu. And this is like software advanced type of skill, but it's a skill we can all do. And as long as you don't save the document, you're not going to mess anything up because you can start over. And what I'm going to do is I'm going to go into actions. And there's this hide show action. And when I click on hide show, you can see all the stuff that's going on behind in this lovely little activity here. And what I want to do is I want to find this F1, and I don't think I'm going to find it on this one here. So I'm going to go right here. So again, I went into menu, I went into actions, I went into hide show. And what I'm looking for is I'm looking for F1, which is ax squared plus bx plus c. And if I click on it, I now can see it. I want to show that. And then I'm just going to hit escape. So what I've done is I've shown someone that the author of this file wanted hidden, but I want to see it. And again, as I'm pressing through this, that's really not that useful. Well, other than it does reinforce that the 1 goes here and the -2 goes here and the -3 goes here for C. But what I want to do is I want to change this so I can see the numbers. And on the TI-Nspire CX2 software, you can click on the graph and right click. So I did a right click and change the attribute. And attributes are things like color, weight, type. So this one, I can change that. I can change the way the line looks. I can change whether or not it's f of x or y equals, but I would like it to be f of x. And then this button right here, right now, I'm leaving it as A, B, and C, how it was designed. I would like to put in the numbers. And that's something that's new with the TI-Nspire CX2 software that I couldn't do before. So when I use this in my classroom now, that's important to me. I want them to connect where this 1 goes, because as this changes, the numbers are changing with it. And that might be very powerful as we're actually looking and connecting between the variables. So that's a technology skill that I wanted to make sure that we had as we explored this. Okay. So there's one more thing about this actual activity that I really, really like. And before I show it, I want you to kind of think about, okay, how would you use this last problem or this last page of this activity in your classroom if you were working with discriminants? So I'm going to go to discriminants. And again, if I'm looking at my slide here, that kind of showed me that I'm on problem 4. This is my last problem. And I'm going to leave it the way it is. I'm not going to change anything with it. And what do you notice that's different this time? You can go ahead and type that into the chat if you would like. And so this time there's no discriminant equation. And so one way to flip this, or a way to flip this, is instead of saying, here's the discriminant, what do you notice? We might now ask the question, what kind of number should the discriminant be in this case? And how do you know? That's one thing I can do with it. The other thing I can do with it is I can actually say, go calculate the discriminant. I could have started with problem 4 and I could have had my students practice the discriminant, because I can tell you, even Algebra 2 students have problems with squaring numbers because they don't put them in parentheses all the time, especially at the beginning of the school year. So that's one thing that we could be doing here. So this one is going to have all of them here now. So I had one that had 2 real zeros. Now I have no real zeros. So what would my discriminant be? I have another one. What would my discriminant be? What would my discriminant be? And I could calculate that. So again, it's not so much about always following the script that comes from the activity, but I would encourage you to look at the whole activity and figure out which parts you want to use. And it might be that you're going to save this part of the activity to use as bell work in your class a week later and change the questions up. And it could be that this piece right here might be something that you want to use in a completely different application, but it happens to apply. So I want to encourage everybody to be very creative when they're using those activities. So that one here was discriminant testing. And then at the end, when we send you the files and the link to the recording, I'll also have the links and the activities as well. But these are on the TI-Nspire website, and they're very, very good to do. So I believe I've met my first goal, is to explore some activities that are already done for us. The next thing I want to do is I want to go ahead and just work with numbers and data and different things related to quadratics. So what I have right here is I have some data. It's honestly not very exciting data, but it is some data. And the question is, and this is a simple question, but which function models the data? Simple for math teachers, but that's a high level question for students. And one thing that I have noticed about my teaching over the years is that in the very beginning, I never looked at numbers. And that seems very weird to say, as the fact that I'm a math teacher and I wasn't looking at numbers. And that has changed because I forced myself to look at data and to talk about data with my students. So before we even do anything with this data, I would ask my students, what do you notice about the data? And so tell me a fact about the data that you see up here, just looking at the numbers, all that. So is there a -3 twice? Oh my, there is a -3 twice, and that is a picture. Oh, I will correct that before I send out this file. So this is why you should look at the data. So this should say -3, -2, -1, 0, 1, 2, and 3. So let's just pretend that this X value really didn't repeat. So the input should be -3, then -2, -1, 0, 1, 2, and 3. So if we have the inputs there, so the inputs are a difference of 1 each time, and then the outputs are pretty symmetric, would be one thing that I would do that. So I'm so happy that I asked that question of you guys, because as teachers, don't we mess up a lot? So let's go ahead and work with this data. And so on this data right here, what I'm going to do is I'm going to insert a different type of document. So what I'm going to do is I'm going to hit Control-I, and I would like to do a list and spreadsheet. And list and spreadsheets are so easy to work with. And I'm going to copy the correct data in this list and spreadsheet. So again, I'm kind of modeling this side by side, and I'm going to type in my input. And I was very purposeful in selecting input instead of X values, because if this modeled actual real life data, it probably isn't an X. It could have been time. It could have been height. It could have been anything like that. It is just data though. And then I have my output, and I will type these in correctly. So this is -3, -2, 1, 0, 1, 2, and 3. So I increased my values of my inputs, and then my outputs, I had a -6, a -4, a -2, a 0, a 2, a 4, and a 6. And so there's my data right here. And I'm going to go ahead and make these a little bit smaller right here, just so we can look at the numbers. Now, when we talked about things that we wanted to do with functions, somebody mentioned rate of change. And so I would like to look at the rate of change of the data here. And basically this is a finite differences activity. So I am going to go ahead and say -2 minus 3 is going to be 1. And -4 minus 6 is going to be 2. And so if I were to do that rate of change, it happens to be 2. I'm going to do it again. -1 minus -2 is a 1. So with my inputs, these are a difference of 1 every single time. So I really only have to work over here. And so -2 minus -4 is also a 2. And 0 minus 2 is a 2. And 2 minus 0 is a 2. 4 minus 2 is a 2. 6 minus 4 is a 2. And because these x values here were all a difference of 1, I don't really have to worry about the change in y divided by the change of x. Or rather, I'm doing the change of x inside my head, and it's always 1. And so I see that these differences are always 2. That's pretty cool. What does that have to really do with anything? So someone mentioned that it is so wonderful with the TI-Nspire is to just look at these two inputs and outputs right here. So I'm going to do this again. What I did is I went in the top and I hit my up arrow. You can do it right here. If I hit my up arrow, then I'm hitting my shift key and then going over. I've selected those two columns. And then what I'm going to do is I'm going to go into menu and I'm going to go into data and I'm going to do a quick graph. And I can see that I have linear data. So sometimes, and very early in my career, I would always just kind of graph the data and then look at it. It'd be kind of nice to analyze the data and realize that there was a constant rate of change. In fact, when I did that, I'm looking at my slope, so I can go back into my menu, and I believe it's under Analyze. I can plot a function, and this function was 2x. Simple data, but important data. Well, we're talking about quadratics. So let's move on to the next problem. So we're going to do the same idea. And so again, the question is which function models this data? And since we're here, we can just kind of look at it. And it's the same bad typing. I apologize for that. But I was good with my typing. 3, -2, -1, 0, 1, 2, 3, and it's a picture. I can't even change it. But my y values are there. Again, I gave you something symmetric. But this time, everything is positive. So we're going to do the same thing. We're going to make the same chart. So I'm going to insert, this time from the software, I'm going to go up to Insert. And I'm going to do a list and spreadsheet. Up at the top, I'm going to label it Input. You always want to have your columns identified, especially in the Nspire. And then I'm going to type in my values. -3, -2, -1, 0, 1, 2, 3. And sometimes I provide that for my students, but if you do too much for your students, they will be able to go out in the world and do things on their own. So this is simple enough that I would have my students do this with me. And so our outputs were 9, 4, 1, 0, a 1, a 4, and a 9. And on the computer software, it's really easy to type that stuff in. And so I want to do the same thing. I want to look at the finite differences. We kind of get the idea with the x's in there. And so for this one, I'm going to do 4 minus 9, which is -5. I'm going to do 1 minus 4, which is -3. And in my classroom, I would have a whiteboard up and I would be doing all this work out there because sometimes that confuses students and they think that I just magically know how to do this. And then it's 1 minus 0, which is 1, 4 minus 1, which is 3, and 9 minus 4, which is 5. And as I look at this, they're not the same this time. And so a concept with quadratics is that we really do want to look at what's same and what's different. And with finite differences, you would go and you would find that rate of change again. And so -3 minus -5 is 2, and -1 minus 3 is 2, and 1 minus -1 is 2, and 3 minus 1 is 2, and 5 minus 3 is 2. And I now have a constant relationship there. So it took me 2 tries to get that, which kind of indicates that it's a quadratic. But I want to kind of look at the graph as well. So again, I'm going to select that graph. I tend to go to my calculator and always show the steps on the calculator so that my students get that. And I am going to do a quick graph. And this quick graph is a quadratic. And so when we were looking at rates of change, and I think this is kind of important to bring up right here. So this column right here, I'm just going to highlight the rates of change, that first rate of change. Maybe I'm going to. Here it is. So we had a rate of change of -5. That's when the function's decreasing. At a rate of change of -3, that's when it's decreasing. And we can see that this is steeper than that one. If we were to connect it with segments, those rates of change, this average rate of change between those 2 points, then we had a -1, again decreasing, and then we had a +1 increasing, a +3 and increasing, and then the other one was a +5, which was increasing. So it's really kind of important to connect the numbers to the picture and maybe not always have a smooth function. So again, all I did is I had some data and I just picked a quadratic with easy enough numbers to type in to look at those values and simple enough numbers to calculate in my head. All right. So any questions, comments? And yes, definitely paper and pencil for this too. You know, if we have graph paper, we're going to plot graph paper and we can do it a couple different times. It's really powerful for them to see this in multiple ways. So if they've done it with paper at one level, let's do it quickly with a calculator or with this computer at another level and move on from there. So, all right. Let's go back to where I'm at. So we've worked with data. We've done 2 activities here. And so now we're going to kind of get into an applied setting. Okay. Now, I'm a math teacher. This is really a fake situation here that is really bad, but there it is. So we're going to toss wadded up pieces of paper into a trash can. Okay, this would never happen in my classroom, by the way. They're not allowed to wad up pieces of paper and throw them into the trash because we recycle paper, and I talk about that volume takes up more space than a flat sheet of paper as it goes into my recycling. So if I were to do this in my classroom, it actually would be a fun day type of thing. So we're going to wad up paper, we're going to throw it into a trash can, and this toss can be modeled by this function. So we're actually going to go with the fact that we have gravity and we have this physics thing, and here's an equation that's going to model the path of that piece of paper. And again, contrived situation to get to what we want to do. I'm defining x to be the horizontal distance from the point of origin, and I'm defining y to be the vertical height of the paper as it's moving through the air. So that's the situation for where it is. And that's all I have. So we're going to do the same thing. So I'm going to go into my software and use the insert, and I would like to see a graph of this particular formula right here. And I'm going to go ahead and type it in, and I have no idea what my F1 is. Oh, my F1 is that. Probably because I solved it there. I did that previously, but we're going to type it into F1. So F1 is going to be -0.03x squared plus 0.02x plus 2. And before I press enter, there's some things that I would hope my students would be able to tell me about this particular model. So in the chat, will you guys tell me some things that you would hope your students would tell you about this particular model? And it's 0.02. There we go. All right, so upside down parabola. What about the whole number 2? It's going to have a y-intercept of 2 going to face downward. Do we have any idea? So if it's facing downward and it has a y-intercept, could we predict the number of zeros it would have without calculating a discriminant? So we can even connect all of those pieces in there. I'm going to press enter, and here's the picture. That's not too bad, really. And some things I love about my TI-Nspire is that I can just drag things around. I really only need to see this part of the graph. I don't need to see the stuff below it, and I don't need to see the stuff over here. So in my classroom, I tell them to click on that number and change it. So I'm going to change it to -1. And then you press tab. And I have to decide if I like 8.3 or not. And my classroom probably has 10-foot ceiling, so I'm okay with 8.3. Maybe I'll make it 10. And then over here, 15 is a little bit far from there, so I'm going to change that to 12. And I'm pressing tab, and tab's allowing me to go around a whole bunch of times. I do want to see some space around my graph, so I'm going to leave this -4.9. And if I just keep on pressing tab, I can bounce around. And so that's one way to get a pretty graph. I don't want to see 0.5 feet here. I want to count by 1 feet. We're going to pretend I have tile in my classroom, and so it's really easy to count that. And there's lots of different features that we could talk about this. We could talk about the y-intercept, we could talk about the zero, we can use all the features of our TI-Nspire. But what I want to do is I actually want to model the path of this. In fact, I'm going to go ahead and change this to 5. Change this to -2. I'm going to change it just a couple more ways right here. And in our TI-Nspire, if I do menu, I can trace and I can graph trace, and I can start at 0. And that would be where I would start throwing this wadded up piece of paper, and I could see what happened at 1, 2, and I'm just typing in the numbers, and I'm seeing the motion of the path. And that pretty much is how we had to do things for a while. And so I can guess between 8 and 9 feet away is where this paper landed, hopefully in the trash can. So I'm going to hit Control Escape because I didn't want to mark that. And I'm going to escape out of that because I really don't want to do that. What I want to do with my students, and my students don't have the TI-Nspire CXs in their hands, but they see my software. I'm going to go into Menu, Trace, Path Plot, and I'm plotting a function. So now I can actually play this movie, and it is amazing how attuned students will be when they see this movie. So I'm going to just go ahead and start it, and we can see the path. The way I have this problem set up, the horizontal distance away and the vertical distance away. And I can stop the movie, I can pause the movie, I can hit my left and right arrows, and I can control the movie, which is kind of cool. So I can start the movie. Now, when I'm doing that, it's a little bit harder to land right there on that y-intercept. If I just press the 0, it will jump me to that. And then I can control the movie from there, which is pretty cool. So if I'm talking about the motion of something, it's very, very valuable to model that motion. And I can see that my y-intercept is at 2. So if I'm standing here, the paper is 2 feet above ground, probably doing the underhand, and I'll pretend I'm very short to get 2 feet. Now, a question would be, is how far did it go? Which means I need to get this answer right in here, and how close could it be? And estimates from there. But this path plot was the one feature I wanted to make sure that I showed, because it's a new feature, so not necessarily one that's in our minds all the time. Now, another thing I could do with this function is I could go up to it, and really, it doesn't make any sense to talk about distances behind me unless I threw it behind me. So one thing that I can do is I can hit this Control equals. And in my classroom that we deal with restrictions, again, we deal with restrictions in our freshman year, I can restrict this so that X is only going to be greater than or equal to 0. And that changes the visual as well, which is something that's kind of important here. And that'll still work with the path plot. So I can still do my trace and I can do my path plot, pathing a function. The thing is that it's going to count down. It's going, oh, reset. It's going to count down from before that, but then it'll start showing once the function is defined. So that's pretty cool to do right there as well. So I wanted to kind of talk about some features and of the calculator that we can use in all of our classrooms. Other things that we would want to do, and when you hit escape, that's going to go away, is just as a reminder, we would be analyzing the graph and we can find the 0 and mark it. And this is a funky parabola right here. So if you hover on it and hit the plus key, you'll get more digits. And if you hit the negative key, you'll get less digits. So I can force it to 8.5, but it's really not. This one should be some digits there. So that's another feature. As a calculus teacher, it's really important to me that my students can give me 3 digits at any point in time. Someone added in here, what about the height of the trash can? So we'll say the trash can is, we'll say it's 1 foot high. So now, definitely probably didn't make it if the trash can's right here, but there's other issues that we can deal with that. So those are some important things to kind of think about. Did we get blocked if this is really where the trash can landed? So there's more things to the story that we definitely want to put in here. That's real important and easy enough to do. On this one, does it look like we have the maximum within, like, did I actually curve this up enough to have a maximum before or after? So that's another thing that we can look at with this particular function. And that might be where we just want to say, feeling that once I put that interval in there, I'm just going to say that x is going to be between -3 less than or equal to x, say, oh, I'm probably messing this up and I probably shouldn't mess with that at all. So I could look at this graph right here and just, again, analyze the graph and say, can I find the relative max? Well, it'd be the absolute maximum. And so on this graph, the maximum happened to be right here as I hovered around with it. So some features about the calculators. So an idea to think about. And again, I didn't do anything special. I kind of found a problem in a book and I adapted it in order to make this work, just so that we can talk about the features. Now there's another way this application goes, and I want to discuss that before we leave. And this situation right here is a dynamite blast. So I have a dynamite blast. It sends a rock straight up into the air. It has a launch velocity of 160 feet per second. The height of rock is modeled using the function ht, where t is measured in seconds and h is measured in feet. So this is another quadratic situation. The catch is that the physical situation does not look like a parabola. And this is the other piece, is as students mature and we have different problems, we need to make sure that we understand if the problem is modeling the motion of the object or if the problem is just the data coming from the motion of the object, because this object is going straight up and straight down, and yet it's being modeled by a quadratic function. And so the function is telling us height as we input time. And so we would do the same thing for this one. And on this one, I do not have a graph, so I'm going to insert a graph. I'm going to use my cheat right here of typing this in. Now, what's kind of cool, the way I did this on this particular feature is I had this h of t over here. And if because of the way I defined it, I have a variable right here, so I can put my h in here, and I just need to make sure I'm going to graph h of x on this graph. And I definitely do not have a window that's friendly. It's nothing that I can see anything other than I have an up and a down. And so again, we could guess some numbers here. I'm just going to type in 100 and see if that's working for me, and that's not good enough. Another thing that I do is sometimes I'll hit Control T. T is for table, and table starts with T, Control T. And so sometimes I'll put the table in just so that I can see values here, and I can see that, wow, it looks like I at least went up to 400. Again, how can I have more data talking about things? So I'm just going to change this to 500. And then if I want to get rid of my table, I can hit Control T. And then I have my parabola, and I can go through and start doing the different things this way. So some ideas about quadratics. We are nearing the end of time. And so I hope that I have met my goal by talking about some resources and some other features about technology. And I hope we all had fun. So Stacy, do you want to kind of close out?
Yeah, I think it was great. As a chemistry science teacher, I may be having some physics classes next year. I told Kim I was definitely looking forward to tonight. I know how I'm going to put it into my classroom using the TI resources. So thank you. It was great.
So someone mentioned that they are going to watch this again because you're doing things I was not aware of. So my task tonight, my homework tonight, is to kind of do a little handout to go with this. So I will put some specific keystrokes in as just little reminders of some stuff, just because I specifically picked some tactics or some strategies to work with data so that we're not always tied to one way of doing things. So I thank everybody who's taught me those things before this as well.
Great, thank you. I am going to put in the chat window as well your certificate of attendance information. You will get an email a couple of days after the webinar that has your certificate of attendance, but you can click on that link and download your certificate of attendance, as well as a brief survey will automatically appear in your browser. If you could please give us feedback, this will help guide us into our future online events, and we do appreciate your thoughts. If there are any skills or a repeat of tonight or other resources you'd like for us to cover in a future webinar, please let us know in that survey. We definitely listen to your feedback and hope you will share your thoughts in the post-webinar survey. After the session as well, if there is something that you may need, there are useful resources to help answer your questions, as well as maybe some technology tips. 1-800-TI-CARES is definitely a phone number to reach out, or ti-cares@ti.com for an email address. They listen to us. They listen to teachers. Please, if you have any questions or concerns, please contact them. We do have some more webinars coming up along the similar lines that were modeled after what our international conference would look like. Next week, next Thursday, same basically date and time at 7 p.m. Central, 8 p.m. Eastern. We're going to model the spread of diseases with real data using the 84+ CE, as well as the TI-Nspire CX technology. And then we're going to look at mathematics behind social distancing using the TI-Nspire app. So thank you guys so much for joining us tonight. Kim, thank you so much. I always learn when I attend these webinars. I learned a lot from you, and I hope everyone learned a lot about quadratics and some technology tips. We hope everyone stays safe and see you online again next week.
Bye, and thank you.